Yes, sir.
Okay.
Hi, I'm John Merrihew. I'm the Government Systems Vice President for Veloxiti. We're a small, agile software company out of Atlanta, Georgia. And we do most of our work with the government, with DARPA, and in particular the Army, CERDAC. Most of this technology you're going to see today is technical readiness level 5 and 6, has been in labs, have been in some exercises, and we'll talk to you about that. Okay, I have the Colonel's slides up. So we're going to be talking about intelligent agents here. So some people call this artificial intelligence. We hate to use that term because artificial intelligence expectations in the 1980s and 90s kind of failed, and things that are successful in artificial intelligence are just considered regular products. Things like the Google search algorithm are used today, and nobody calls that artificial intelligence. So our belief system is the OOLOO. And this is a comment by General Dempsey when he was the chairman. And he's looking for people that think like Colonel John Boyd. So John Boyd is a very, very interesting person. He was an acquisition officer and a fighter pilot, and he came up with a theory of how to think about combat. So he was 47-0 in 3 wars, World War II, Korea, and Vietnam. He was also an acquisition expert, and he was the one who invented the twin-tail aircraft. Came up with the maneuverability as opposed to your single-tail aircraft. He also had a small office right next to Dick Cheney and General Powell during Desert Storm, and he was the one that advised that came up with the ideas of that 4-day war, which were pretty cool. So our underlying technology in the software revolves around this idea of you're always observing, always orienting, always detecting, and always acting again and again, much like the human brain. So you can see the OOLOO loop right there. So this software package that we've built, everything you see here is government purpose rights, which means it's absolutely free to the government, and we use, this cognitive engine often in many of our projects. So the OOLOO loop and problem solving, I've already discussed that. So the environment is very complex. I think that was highlighted yesterday by the Secretary of the Army that says war is a human endeavor. There is no doubt. There's a lot of similarities between the Romans and Greeks 2,000-3,000 years ago. However, there are a lot of enablers, a lot of sensors, a lot of detectors. There's a lot of things going on that can help the individual soldier on the ground. And so let's talk about those. Sensors, they're becoming much more networked, and they're connected together better through middleware. Beliefs. So what you're seeing here, this intelligent agent is actually a knowledge engine. It has subject matter expert knowledge in it. And we've built a very intuitive user interface for commanders and staff officers to input knowledge into the engine and execute it at runtime. Monitors, so our graph is not just simply one graph, it's not a set of production rules. There are actually 2 graphs in here. One orients on the world and the other takes actions. It has goals and it has plans. So this is the way we use our software product to support the Army and the projects we're on. I really like to talk about some of the innovative things we're doing to let you know kind of the world ahead. So the next 50 years of combat is going to revolve around our smart systems. I see a couple new aircraft out here that the Army wants to buy, but the ones we're flying right now, the Blackhawks and Apaches, are going to be around another 50 years. And we have to make them smarter and better. We could do that through middleware and software. Okay, I mentioned these graphs. So this is in a Java engine, so it's pretty easy to use. but usually our government customers say, you put the knowledge in for us and help us. And usually they'll provide an SME for us to help them integrate this system. The other thing I could say about this engine is it's totally agnostic. It's run in the Kyle Warrior. We've done experiments where a Kyle Warrior pilot was able to control 4 sets of UAVs, look at 4 different targets while prosecuting the targets that he's in his aircraft. It's run in Command Post of the Future, FBCB2, and numerous other command and control systems. This is the cognitive engine itself. It is available for commercial customers, but I'm really here for the government. Folks that would like to use this engine, I've listed my customers here, and you're also able to go over here and see live demonstrations of some of the capability. This is not a movie. This is real software. Okay, the S6. This is an interesting project. We were funded for 3.5 years to do this. We read the entire network, and we manage the network for the S6 officers. So the network officer at Brigade, normally, if you walked into his talk, he'd have anywhere between 50 and 75 laptops, an army of contractors managing the separate laptops. And what we did was built an application that read all of those laptops, read all of the information, and also read all of the tactical situation. Your common operational picture, everything in Command Post of the Future, some of your things in military intelligence, and also reads everything in military chat. Not in one room, not one user, not one server, every server. So you can imagine that's a pretty sophisticated natural language processing problem. It's not quite as simple as just tapping your phone on the Google Android and say, take me here or take me there. But all of that's embedded in here, and this system will eventually be integrated into WinT, we hope. So that program is on its way, and it's had some starts and stops, and it's had some challenges and hurdles, but we're working very closely with the program manager to try to use some of this capability. Common Software Foundation is an interesting project out of Command Power and Integration and CERDAC. It actually tries to break down all of the stovepipes. So we're 6 months in. Both this one right here is an SBIR Phase 2. So it's a small project, but we've taken a Link 16 track from the Air Force, a FBCB2 track from the Army, and information in CPOF, and we've fused that and made sure we could pass it to all the different systems using middleware with no software engineer involved. Nothing but the user. It also manages quality of service. And you can see it has a user interface, and these are functional slides, and I have my lead engineer here. He could talk to you about this more. This is an interesting project. This is funded out of the Army Research Organization. This system reads ground movement target indications, ground surveillance radar. So if you do a radar mission, let's say you're on a JSTARS Air Force aircraft, you'll come back with hundreds of thousands to millions of tracks. We probably have 25 to 50 people in the Army that can actually read all of this radar data, make sense of it, and say, this is a vehicle and it's going from one place to the other. It's a very difficult science. So I commanded an Army unit down at Warner Robins, a military intelligence unit with Army military intelligence officers and NCOs. I could only train 3 of the 130 to actually do this. That's how hard it was, because you only had 6 months. So by the time someone got up to speed, now it was time for them to PCS, or worse yet, ETS, and I'd see him at one of these alphabet soup organizations here in Washington, D.C., doing the same thing for an organization. Very, very difficult. So this actually reads the tracks. We use a statistical algorithm in here that was developed for Wall Street that actually does trend analysis on stocks. So you've heard about these technologies that have computer trading. The computer beats the human into if it's going up or down. We've done the same thing here, and then we've read all of the chat and all of the other information, and it does 2 things. Number 1, it tells you when there's an enemy TPP of something happening, the enemy's doing something with a ground vehicle, that you should raise your force protection. Go from a green to an amber to maybe a red, or maybe you come to a dead stop and you do an ISR cross-cue on that target. The second thing it does is after an ID has gone off, it does past analysis of where all the vehicles have been, and it tells you in the network with some level of certainty where the bomb maker is, who planted the vehicle, where did the vehicle go, with the person who planted it, who exploited it, and who the network leader is. So kind of a forensic tool in addition to a real-life warning tool for soldiers. That demonstration is right over here that we're able to run if anybody wants to see that. This is an interesting project. We're working with our main contractor, Sikorsky. This is a DARPA project that basically wants to take knowledge acquisition and read PDF and Word documents, put it all in a knowledge base, make sense of it, make software code into it, and pass it directly into the aircraft. So we're in our first year of this. The aircraft is flying with the knowledge base on it, and we're making tremendous progress here. And the hope is that this system will be able to fly autonomously by itself. So for the military, the application is pretty simple. If you've got kind of an ash and trash mission way back in the rear where you're not flying soldiers, maybe MREs in water, you let the autonomous Black Hawk fly that. You've got a mission maybe from the rear area to a forward operating base. Pretty simple mission. You fly with one pilot and you let Alias, the knowledge-based system, help you. If you run into any threats, the system will help you, give you new directions, tell you new altitudes. And if it's a really complex mission, special forces mission, air assault mission, coordination with longbows, fighter aircraft, both pilots and the system is kind of a third pilot to help the two pilots. So you see everything in here. Nothing's happening in each of these technologies that the human isn't involved and making the human better. So we're human design focused people. This is not to replace soldiers and aviators. It's to enhance their capability using middleware. The background of the company, we've been open 25 years. We've been doing this stuff a really long time. Our founder, Norm Geddes, was on the Pilot's Associate. He built that. He started his own company. The Rotary Wing Pilot Associate is interesting. That was built actually for the longbow, but their money had run out on it, and it didn't get deployed on the longbow. It was supposed to go into the Comanche. That didn't happen, but much of that technology is now on the LAS project. And that's kind of the history of the autonomous part of this. All right, those are my slides. I know I went quickly. Are there any questions of me about what this does? I know this is a little off the beaten track. I noticed there's a lot of medical domain here, and this is really bare bone network ops, intel, operations, and fires.
But if you go back to so this is the TRADOC technology imperative about human performance optimization. And part of that human performance optimization is an improved human-machine interface. So that's part of it, where we're talking, a lot of it's internal, and that's why we have Colonel Dr. Solomon here and some of the other, but we also want to make sure that we include that portion of the interface side. So I think we're right on in the right category. But there's a lot of information, so some questions?
I have a booth here. I'd be happy to run the demonstrations for you all. I brought one of my senior engineers out so you could see this capability, not in a movie, but for real. And I'd be happy to discuss where this technology is deployed in the military and how you could use it in your government organization.
Were you involved in the CPOF effort, or?
We were involved with the CPOF effort.
Okay.
Yes, initially in CPOF back in 1999 and 2000, there was a tremendous amount of intelligence in there.
Yeah.
But by the time it deployed in 2006 to Iraq, all intelligence has been pulled out. What happened was they did put a little tiny bit of intelligence in about 4 years ago, a thing called the personal assistant that learns. That is Siri today. The soldiers hated it, and they hated it because they could only make 3 rules, if, then. And to make a rule, they'd have to go to the field service representative, have the request sent back to Scottsdale, the General Dynamics, over to the Pittsburgh guys, the artificial intelligence guy at Carnegie Mellon, and then they ship you out a disk 60 days later. That does not help. So my customer at Certec said, John, can you get rid of all the software engineers here? I said, yes. So we did that work, and we actually took all that knowledge and put it in a user interface that a soldier can change his own rules if he'd like to, right there on his handheld. So if he's out on a mission and he's in a ditch in Iraq and he's lost his air cover, he can put in a rule that says, if there's an ISR platform or somebody that can help escort me in this last 5 kilometers of the FOB, let me know. So that's the kind of technology we're talking about here.
Okay, great. Thank you.
All
I
right.
really appreciate it.
Thank
That
you,
was
sir.
excellent.